If you've ever played with magnets, you know that opposite poles attract and like poles repel each other.
Japan called for introducing a magnetic levitation railway connecting New York City and Washington.
Most people think trains need wheels to move fast. They're dead wrong. Right now, in Japan, there's a train floating 4 inches above its track, moving at 374 miles per hour with zero friction. I'll show you exactly how magnetic levitation works, why it's revolutionizing transportation, and the mind-bending physics that make a 500-ton train literally fly. But first, you need to understand why everything you think you know about trains is about to change forever. Here's what nobody tells you about maglev trains. They don't just eliminate friction, they completely rewrite the rules of physics. While regular trains fight against the ground, maglev trains use the ground to fly. There are 2 ways to make a 500-ton metal tube levitate, and both will completely change how you think about magnetism forever. Let me show you the first method. It's called EMS, or Electromagnetic Suspension. Picture this. You have powerful electromagnets on the bottom of the train and a ferromagnetic track below. Now, here's where it gets crazy. The electromagnets don't push away from the track, they're actually attracted to it. But here's the genius part. A computer system adjusts the current 1,000 times per second to keep the train hovering exactly 10 millimeters above the track. If it drops even slightly, the magnetic force gets stronger and pulls it back up. But this creates a massive problem that nearly killed the entire maglev program. I'll show you how Japan solved it in a way that will make your head spin. The problem with electromagnetic suspension? It's like balancing a pencil on your finger while blindfolded. One tiny miscalculation and the entire train crashes into the track at 200 miles per hour. That's why Japan said, "Forget this," and invented something that sounds impossible. They created a train that levitates using superconducting magnets cooled to -452 degrees Fahrenheit with liquid helium. These aren't just powerful magnets, they're so strong they can levitate the train 4 inches above the track. And here's the mind-bending part. When these superconducting magnets move over the track's coils, they create their own opposing magnetic field that literally pushes the train away. It's like the track is allergic to the train and keeps pushing it higher. But now you're probably thinking, how do you power a train that's floating in mid-air? The answer involves the same technology NASA uses to keep the James Webb Telescope cold in space. Here's what will blow your mind. Maglev trains don't just levitate, they turn the entire track into one giant motor. Let me show you how this works because it's pure genius. Traditional trains use motors to spin wheels. Maglev trains take that same motor and unwrap it along the entire track. The track becomes the motor, and the train becomes the moving part. By switching the polarity of electromagnetics in the track, they create a moving magnetic wave that pulls and pushes the train forward. This means the train never touches anything, never wears out, and can theoretically go as fast as physics allows. The only thing stopping it? Air resistance, and engineers are already solving that with vacuum tubes. But here's what's really crazy. The magnetic fields are so powerful they had to redesign everything. The passenger cabin sits in a carefully engineered magnetic bubble, where the field strength is no stronger than Earth's natural magnetic field. So here's what we've discovered. Maglev trains work by turning magnetism inside out. Instead of fighting friction, they eliminate it completely. Instead of using wheels, they use the track itself as a motor. And instead of being limited by mechanical parts, they're only limited by air resistance. The Shanghai Maglev covers 18 miles in 7.5 minutes. Japan's new line will cut a 4-hour journey to 1 hour. This isn't just faster transportation, it's physics-defying transportation. Now you understand magnetic levitation better than 99% of people. You know why these trains can hit 374 miles per hour, why they need superconducting magnets, and how they turn an entire track into a motor. But here's what I didn't tell you. There's an even crazier transportation technology that makes maglev trains look slow. It's called the Hyperloop, and the physics behind it will completely change how you think about speed itself. If this blew your mind, hit that like button and let me know in the comments what transportation technology should I break down next. Subscribe for more mind-bending physics explanations that actually make sense.